Alright, so let's now move on to our cosine function. So for our cosine function, this is going to be very, very important. We're going to have a new starting point. So if we were to graph the angle theta as we are going around that trig circle, that unit circle, well, we know that at an angle of 0 degrees, you are now starting at a value of 1. At an angle of pi over 2 or 90 degrees, you end up at a value of 0. At pi, you end up back at a value of 1, but now it's negative. At 3 pi over 2, we end up at 0 again. And at 2 pi, we end up at the exact same place that we started at. So, what we're going to do is we're going to say that our starting point is now the maximum or the minimum. So, rather than starting at hk, we're starting at the top. So, at the top of your mountain or at the top of your pool. So, in this case, we start at the 1. This is your halfway line. So your starting point is actually going to be at h and k plus your amplitude. Because what does this represent, this height from here to the halfway line? Well, that's your amplitude. So therefore, if this is h and k, then this is going to be h and k plus a. Additionally, we can also have the same thing if we were to start at the bottom, at the minimum. This would be, again, your h value, but now your k would be subtracting a from it because you are below that value. And this is all to say that this point on the halfway line represents your h and k, or this point on the halfway line represents your h and k. So h and k is always on the halfway line, but in this case, it's not your starting point. That's the important thing here. So that's what makes cosine a little bit trickier. Your h and k is not your starting point. Your h and k is on the halfway line. Your starting point is either hk plus a or hk minus a. So let's start graphing this cosine function now. Again, we have several steps to do this. Our first step is that we're going to find all of our parameters. So our parameters hk, little a, big A, little b, and period. Then your second step is you are going to find your h and k, which in this case is not your starting point. You're going to draw the rectangle with the height that's equal to 2 times the amplitude and the length that's equal to your period. Then you find your halfway points and your quarter points that are going to be in this rectangle. Now here's where it's different from the sine function. If your a is greater than 0, your function starts at the top corner. And you are smiling because it's going to be decreasing. And if a is less than 0, your function starts at the bottom corner, and it would have to increase, so therefore it would have to be sad. So it's like a sad face. And then you would draw one cycle in the box. So the majority of the steps here are the same, except for step number 5, because for your sine function, if we remember correctly, it was a times b that we cared about. But in this case, for cosine, we only care about parameter a. Parameter b does not affect the flipping of your function. So if b is negative, it does not affect if it's increasing or decreasing in this case. So, example number 1. Y is equal to negative 2 cosine of pi over 4, x minus 2 plus 1. So, step number 1, we said we find all of our parameters. So, our h is 2, our k is equal to 1, the amplitude is 2, and in this case your little a would be negative 2. Your b is pi over 4, and your period in this case would end up being 8 because 2 pi divided by pi over 4 is 8. And because we know that a is negative 2, we're also able to say that it's less than 0. And if it's less than 0, this is going to help us draw our function. So our next step is find your h and k. So your h and k is actually in your function. It's the parameters that you solved for. So it's going to be 2 and 1. That's my halfway line. From there, I now need to add my period. I now need to say, okay, well, where am I starting? Where am I ending? Well, if I'm starting at 2, I need to finish at 10. And if my k is at a value of 1, and I know that my amplitude is 2, I'm going to go up to 3, and I'm going to go up to, down to negative 1. So this would be my box. And again, your period would be 8. So once this is done, I now need to say, okay, well, what do I know next? I know that I have an ending point, and I have my halfway point. And there they are. Now, why am I drawing them on this halfway line? Just because it's going to be easier for me to decide if they remain there or if they go up or down. And then I have quarter points. 1 and 2. Now let's ask ourselves, where's our starting point? Well, if a is less than 0, we're going to be frowning. So we're starting at the bottom, we're going to go up and end at the bottom. So if we end at the bottom, your last point on that rectangle that you drew has to be at the bottom, which means your halfway point needs to be at the top. So in other words, you're starting here, you go through this imaginary point, you then reach the top, you go through the next imaginary point on the halfway line, and then you reach the bottom. So your function should look like this. Now this would be just one cycle of your function. And these are all those dots. So let's move on to our next one. So y is equal to 3 cos negative pi x minus 2 pi minus 1. So in this case, the first step we need to do is we need to factor out that negative pi. So when I take out that negative pi, I get a h of negative 2, a k of negative 1. The big A, my amplitude is 3 in this case. My period would be 2. And the value of A is 3, which means that it's greater than 0. So let's start plotting our h and k. We would be at negative 2 and negative 1. My period is 2, so I finish at the y-axis, and my amplitude is 3, so if I'm at negative 1, I need to go up to 2, and if I'm at negative 1, I need to end at negative 4. Now, where am I starting? Well, h and k is negative 2, negative 1, but I know that my function is going to be happy. He's greater than 0. So therefore, my dot starts at the top. So your halfway and your quarter points are there just to help you starting to determine where you're going to be crossing on that halfway line. So you're starting there, you end up ending at the same height, but halfway you're going to be at the bottom. So this makes this function a smiley face, which means that you are decreasing at first. So this is what your function will look like, and those are the halfway and quarter points that we had plotted on that halfway line. Alright, now solving the trig equations with cosine. So this has the same procedure as the sine function, but one thing is just a little bit different. Rather than using pi minus your angle to get the second one, you're going to do 2 pi minus your angle to get the second one. So let's solve this function. Negative 2 cos pi over 3, x plus 1 plus 0.5 is equal to 0. So the first step is always finding that period. So in this case, I know that I'm solving for the 0, so I'm going to do 2 pi divided by the b value, which is pi over 3, which gives me a period of 6. I then make everything equal to 0, which I already had. I bring over that 0.5. Becomes negative. I can now divide by negative 2, and I get 0.25. And this is where you ask yourself, do I know this as a remarkable angle? And the answer is no. So in that case, what do? Well, we take the arc cosine. So in other words, you take the inverse. So the arc cosine of 0.25 is 1.32. And once you have this angle, you say to yourself, okay, what is the second angle? Because there's always going to be 2 angles for cosine or 2 angles for sine. So it's going to be 2 pi minus 1.32, and we get an answer of 4.97. So therefore, you make 1 equal to 1.32, and we get an answer of 0.26. You would also make the other one equal to 4.97, and then you would start solving, and you get an answer of 3.75. However, we're looking for all the solutions, which means you need to add 6n to both of them for every time it repeats.